Hi everybody. Now lastly we got a problem, a numerical problem on the basis of diffusional flux for a particular case where carbon was diffusing through iron plate. So what was the problem? The problem was carbon is diffusing through a plate of iron and we are supposed to calculate the flux. Concentration and diffusion coefficient is given and the distance is given. Now how to solve this? Before we go to the solution, we review what was the particular equation which we came across, that is nothing but Fick's first law, which is actually correlating the diffusional flux with the concentration difference. So we are supposed to calculate dN dt, or we are supposed to calculate the flux, that is 1 by A dN dt. We are given the value for dC, that is C2 minus C1. The thickness of the metal plate is given, that is x2 minus x1 or dx, as well as the diffusivity coefficient of carbon with respect to metal iron is also given. So easily employing the Fick's first law, we can calculate J. Now let us put the value on the equation. Now therefore J is nothing but, as we have already went through the Fick's first law, that is J equal to D into dCA by dx. dCA is nothing but CA minus CB and distance is nothing but XA minus XB. So D value is given to us, that is 3 into 10 to the minus 10 in SI unit, meter square per second, and CA minus CB, the distance is 1.2 minus 0.8, that is concentration at the point A was 1.2 kg per meter cube and this was 0.8 at the point B. So distance of point A with reference point with respect to reference points is 5 into 10 to the minus 3 meter, and with respect and for point B with respect to this reference point, this is 10 into 10 to the minus 3 meter. All of the values are put in terms of SI unit. So simple calculation will give you 2.4 into 10 to the minus 9 kg per meter square second. So flux is expressed always in terms of mass per unit, that is area, 1 meter square area, unit area, or unit time, that is second. So this is the flux what we have calculated out for this particular case. It must be very low amount. We know molecular diffusion is very slow process, so parts second in a second for 1 meter square area, through 1 meter square area only this much kg of 2.4 into 10 to the minus 9, very low amount of that particular carbon will be diffusing through the metal plate. So this is quite low value, and we know as the plate is of metal, so through metal diffusion process is obviously expected to be very slow. So if you have carbon inside a metal packaging material or within or one side of a metal plate, you should not expect much carbon is diffusing through that metal plate across the thickness of the metal or after the metal wall diffusing for a particular moment. So this was a problem of diffusion. Now we will be again undertake some more problems, more numerical problems and other application problems in due course. So this was one numerical problem. Now we will be in next class we will undertake another application type of problem. So thank you for today's topic. See you on next topic with some application problem. Thank you.